All right, let's jump right in. You know, when we talk about fighting climate change, our minds usually go to these huge, flashy things, right? Massive solar farms, sleek electric cars. But what if I told you one of the most powerful tools in this fight is something you've probably seen a million times, just quietly spinning above your head? Today, we're going to uncover the absolutely surprising power of the humble ceiling fan. But first, a quick question for you. What do you think is one of the world's biggest sources of energy-related CO2 emissions? Go ahead, take a guess. Is it heavy industry? Maybe all the cars, planes, and ships combined? Just think about it for a sec. Okay, you ready for this? The answer, and this one really surprises most people, is our buildings. Yeah, you heard that right. Buildings and construction account for almost 40% of global energy-related CO2 emissions. That is a huge slice of the pie, way bigger than a lot of the other sectors that get all the attention. So, what's the main culprit inside these buildings? Well, it all comes down to keeping us comfortable. It's the heating, ventilation, and air conditioning, what we call HVAC. These systems are running pretty much 24/7, just guzzling incredible amounts of power. And a lot of that power, you guessed it, still comes from fossil fuels. And this is where our hero finally enters the picture. Now, I want you to get that image of a noisy, wobbly bedroom fan out of your head. This is something totally different. Meet the HVLS fan. That stands for high volume, low speed. And really, it's like a whole new spin on a very, very old idea. Honestly, the difference is just night and day. Think about a regular fan. It spins super fast, making this little chaotic jet of air. It's loud, it's not very efficient. HVLS fans, they're the total opposite. We're talking massive blades, some are over 7 meters wide, but they spin so slowly, often less than 100 RPM. And because of that, they move this giant, gentle column of air, using barely any energy. And they're super quiet. So the big question is, how can this simple design make such a massive difference? Well, it all comes down to two kind of surprising principles of physics. You could honestly call them its superpowers. Okay, superpower number one is all about summer. It's called the wind chill effect. Now get this, the fan doesn't actually make the room colder, not one bit. Instead, that huge, gentle breeze it creates flows over your skin and helps your sweat evaporate faster. It's just helping your body do what it naturally does to cool down. And the result? You feel anywhere from 3 to 5 degrees Celsius cooler, even though the thermostat hasn't changed at all. And that feeling is where the magic really happens for energy savings. Because if people feel cooler, you can actually turn the AC thermostat up. And the rule of thumb here is just incredible. For every single degree you raise that thermostat, you save about 8 to 10% on your cooling costs. So if you feel 4 degrees cooler, you could be looking at a nearly 40% cut in your AC bill. That's huge. But wait, there's more. This thing even works in the winter. It's superpower number two. You know how hot air rises, right? So in big buildings with high ceilings, all the warm, expensive air you're paying for just gets stuck up at the top, and it's cold down where people are. So what do? You just run the HVLS fan in reverse. It gently pushes all that trapped heat back down to the floor, mixing everything up. And the result? You can slash your heating bill by up to 30%. It's like flipping the heat back to where it belongs. Okay, so that's the science. It's cool, right? But what does all this actually mean for carbon emissions? Let's put some real numbers to it and see the impact. Let's look at a real-world example, a manufacturing facility. Before they installed these fans, their AC was just cranking, using about 100,000 kilowatt hours every month. Then, they put in the HVLS fans, which let them nudge the thermostat up by just 3 degrees. And check this out. They saved 24,000 kilowatt hours, not just months, but every single month. So what does that energy saving translate to in climate terms? Well, that simple change stopped 19.2 tons of CO2 from going into the atmosphere. And again, that's not for a year, that's every single month. So if you zoom out and look at the whole year, it's just mind-blowing. We're talking about 230 tons of CO2 prevented in 1 year from one single building. Now, just stop and imagine. What if we did this in tens of thousands of buildings all over the world? The scale is just staggering. And here's what's so cool about this. It's not just for factories or manufacturing plants. The potential for these fans goes way, way beyond the factory floor. Okay, so think about massive warehouses. You can replace like 50 of those small, noisy, energy-sucking fans with just one of these. or in huge open spaces like airports and malls. They keep the air mixed so the AC units aren't constantly kicking on and off. They can even help improve air quality by pushing pollutants out. And this one is my favorite, dairy farms. They keep the cows cool and comfortable, which reduces their heat stress. And a less stressed cow? Well, it actually produces less methane. How crazy is that? And then you've got to think about how long these things last. You know those cheap industrial fans? They break after a couple of years and just end up in a landfill. HVLS fans, though, they're built like tanks. They can last for 20 years or even more. So what does that mean? It means less waste, less manufacturing new ones, and a much, much smaller carbon footprint over its entire life. So when you put it all together, the massive energy savings, the carbon reduction, the fact that they work everywhere and that they last forever, you really start to get it. This thing is a true unsung climate hero. It's a quiet revolution happening right over our heads. And this, right here, might be the most important point of all. HVLS fans don't create clean energy. They don't generate a single watt. Their power is actually more fundamental than that. They attack the problem right at the source by drastically cutting down how much energy we need to use in the first place. This is all about radical, powerful efficiency. It's like the source material for this explainer said perfectly. HVLS fans really are the unsung heroes of the building energy efficiency revolution. And that really leaves you with one big question, doesn't it? It just makes you wonder, what other simple, elegant solutions to our biggest problems are hiding out there right in plain sight, just waiting for us to notice them?